Okay, hey, how's it going there, pre-calc people? So this is our second to the last lesson for the year. Can't believe it. It's just crazy time, you know? Um, and it's actually an old lesson that probably is not going to challenge you a ton, but it's a good lead-in lesson to what I need you to do the following week. Now, this week we're just reviewing linear systems. So as you can see, the first example I have here and the second example I have here, and I have two more to do. Um, but I'm going to just go through the methods you have available to you in terms of solving these systems, namely substitution and elimination. Those are the two methods. Um, the first two we are going to do are substitution, and I want you to remember something as we do these. Linear systems means that the two equations that are in the problem, if they were graphed, they're straight lines. Okay? So please remember, people, that straight lines, if they are graphed, two straight lines are graphed on the same graph together, one of three things can happen. One, the two lines cross each other. I don't care how they cross each other. It's not important, like if they're perpendicular or two lines cross each other. That means they cross in a point, and that means the solution to the system will be an x and a y coordinate, a point. Your second option is the two lines, when graphed, are parallel and never cross each other. That would be a no solution situation. And then the third example is you have these two equations and you graph them and the two lines fall right on top of each other, which means they share every point, and that's an infinite amount because lines are infinite. They go in both directions forever. And that's what we're dealing with. So I want you to think about that, because we're not graphing, we are solving them algebraically. But those are the three options that can happen, and we have to watch what does that mean. And for us, review, because you did it in Algebra 2 and you probably did it a little bit in Algebra 1. What does that look like algebraically if they cross in one point? What does it look like if they're parallel and no solution? What's it look like if they're right on top of each other, infinite solutions? Okay? Next week, we don't just do linear, meaning all lines. We start messing around with a line and a parabola, or a line and a cubic function, or a parabola and a cubic function. So we start talking about those ideas, which are more complicated and have different solution options. So we'll get to that. This is just a good lead into that. So it's a good, kind of a relaxing lesson that you guys should probably be pretty good at. Okay, what I want you to notice about these two problems is the way they look. Notice in question 1, the first equation says y equals. Please notice when we get to this example, one of the equations says x equals. That's the code for substitution. And here's how we do this. So the first equation says y equals. I'm going to take this, which is what it says, y equals that, and substitute it there. Y equals this. This goes for y. And so we're going to do that. I'll do that right over here. So I'm going to rewrite this equation as x minus 2. And in place of that y, I put negative 3x plus 20. Equals 10. So my job here, I have just an equation with x. You kind of remember this. You distribute, simplify, solve for x. So that's kind of what we're going to take care of next. So this is x. Please remember that's a negative 2, so be careful with signs here. Distributed here gives me plus 6x. Distributed here gives me minus 40 equals 10. Combine like terms, which is 7x minus 40 equals 10. Sorry, just looking at my problems a little bit more. Okay. Solve this, and I'll get to this. I'm going to add 40, divide by 7. So if I add 40, I get 7x equals 50. And I divide both sides by 7, and I get x equals 50 sevenths. Which is not the most pleasant answer, but it's also not the end of the world. Okay? But I want to address that as pre-calc students. Now, I'm not saying that I gave you every problem like this on the assignment. I certainly did not. But I do want you to understand that answers like this are allowed. You do not want to divide this and round it off, because it's going to be close to 7, because 49 divided by 7 is 7. So when I do 50 divided by 7, and I get this 7.1428, I don't want to call it 7.14 or 7.143. You are going to call it 50 sevenths, okay? Because you want this to be exact. We're going to take that. That's our x-coordinate. This means it's not parallel. This means it's not same line on top of each other. The fact that I got an x-coordinate means, hey, these intersect and it's a point. Plug it back in. You can choose to plug this x into this equation or this equation. I'm searching for y, but because that says y equals, that's the easiest one to do. So it'll be y equals -3 times 50 sevenths plus 20. -3 times 50 sevenths is -150 sevenths plus 20. Which I could do, but I'm gonna kind of lazy it up a little bit on the calculator. So I got -150 sevenths plus 20, which gives me -10 sevenths. And that's y equals, which means I write my final answer as 50 sevenths -10 sevenths. And that means if we graph them, that's where they would cross each other. Okay? You can always check your work at this point by, taking this equation, because we worked with this one. But you could take this equation right here, put this in for x, put this in for y, and make sure you get 10. And they're just like, that sounds crazy. Well, it might work. So let's just double check that for a quick second. I'm not going to do it to every one, but I'm going to do this one. So if I do, if I plug, that's 50 sevenths, plus it'll see if I made a dumb mistake. You know that that's possible, right? Minus 2 times -10 sevenths. And I got 10. So that's good. So that's that. And see, this example serves a number of purposes. One, it reminds you how to do things for substitution, even though it's an old idea. Two, it does let you know that answers don't have to be all pleasant all the time. And then three, even though, when you're in Algebra 1, and maybe even a little bit of Algebra 2, but not really, you might have originally solved these by graphing. There's no way you're going to say that on a graph. None of us, including myself, can draw a graph that accurately, though, that I'd be like, oh, that point is 50 sevenths, or, whatever it is, 7 1/7. There's just no way. So this is an exact method. Okay, enough talking, kind of said my piece. Now we're just going to get down to business. Not that this one's incredibly different in terms of, okay, I get it, Mr. L, it's substitution. There's something I want to talk about this example that's a little different. So, first of all, this one says x equals. So, it's going to go in for x. X equals this. This goes for x. I'm going to work this one here. So, this is -2. In place of this x, I put 3y plus 6. And then follow the rest. Plus 6y equals -12. So it's kind of the same deal. Going to distribute, combine like terms, solve. If I distribute here, that's -6y. Distribute here, that's -12. Plus 6y equals -12. Now, when I go to combine like terms here, and you're already seeing this, I hope, that's -6y and that's plus 6y. They cancel. You got to understand your variables just disappeared, but it's what's left that's important. There's a negative 12 left right there, and there's a negative 12 left right there. And I'm not circling that. That's not my answer. That's going to dictate what my answer is. That's a true statement. That's what's really important right there. Negative 12 does equal negative 12. True. That means infinite solutions. Meaning, if we were to graph this, and see, they look different. But if you were to graph them, they fall right on top of each other, and they share every point possible, which is an infinite amount of points. But that's the difference. Now I'm going to warn you in advance, if this statement right here had been false, suppose it had said negative 12 equals 2, then it's no solution. If the variables cancel and it's false, it's impossible and there's no solution, meaning the lines were parallel. But if the variables cancel and it's a true statement, then it's one of the same line, infinite solutions. Okay? Just going to pause the video for a second, erase this, get a couple more examples ready. Okay, so here we go, guys. The final two examples are not going to be substitution. They're going to be elimination. And I want you to look at the two equations that I have this time. Please notice that there's no y equals and no x equals. Everything is what is called standard form, which means x and y on the left-hand side and the equal sign and then a number on the right. And that means everything's perfectly lined up. Okay? X's line up with y's, line up with the equal sign, line up with the numbers. Same over here. That's elimination. At some point here, people, in both of these examples, I am going to add the two equations of the system together to form one equation. When I do that, I want one of the variables to cancel, or as the method is called, eliminate. Right now, if I were to add these two equations together, a variable doesn't eliminate. If I add right now, the x's add to 8 and the y's add to 2. Negative 2 plus 4. So you are allowed to pick an equation. You're allowed to pick both equations, in fact, and multiply both entire sides by whatever number you want. See, if you multiply the left and the right by the same number, you don't affect the equation itself, you just affect its looks. So at the pre-calc level, I'm expecting us to be as efficient as possible. Sometimes at the Algebra 2 level, I talk more about just ease and doing it the easiest way you can possibly see it, which doesn't always translate to the shortest way. We're going to try to do the most efficient, shortest way. What I notice is that the y's are negative 2 and 4. By the way, I'm going to want the variable I choose to be the same number but opposite sign. I notice that if I multiply this by 2, it'll be negative 4. And if that's negative 4 and that's positive 4, when I add them together, they'll cancel. So what I need to do is multiply this entire equation by 2. I can't just do the thing I want. The entire both sides. Okay? So when that happens, I'll write the work down here. When that happens, the top equation becomes 6x minus 4y equals 16. The bottom equation I'm not changing. And I'm going to add those two. Now, listen, you don't always have to add them. You can get the two numbers to be identical and subtract, but it has been my finding, or, I've noticed over the years that students always seem to do the addition better than they do subtraction, so I'm going to stick with addition. So in other words, I'm going to stick with getting something to be opposite signed to each other. If I add these, 6 plus 5 is 11x. Y's are negative 4 plus 4, they cancel. And then 16 plus 28 is 44. And see, we got ourselves a nice reasonable equation there, and it's going to turn out nice this time, not some crappy fraction like 57ths or something. But anyway, divide both sides by 11, and you get x equals 4. Again, the fact that I got an answer for a variable tells me that these two lines are crossing, so I need a y value to make a point. You pick the equation. You plug this 4 back in for an x, whichever equation you want. Okay? I'm going to choose the top equation just because, which means I will write 3 in place of that x. I'll put 4 minus 2y equals 8. If you feel like plugging that into that equation instead, go for it. This multiplies to 12 minus 2y equals 8. I will subtract 12 from both sides, getting me negative 2y equals 8 minus 12, or negative 4. Divide both sides by negative 2, and we get ourselves a y equals positive 2. Negative divided by negative. So our ordered pair is 4, 2. And again, you can actually do one of two things, because this is a fairly nice one. One, you can take the x is 4 and the y is 2, and you can plug it back in and make sure they work in both equations. Or if you have access to a graphing calculator, online application like Desmos, you can plug graph these two lines and see, do they really cross at the point 4 over 2 up, and you can kind of verify that way. Okay, moving on. Okay, another similar example. This one's a little bit more challenging in the sense that, nothing's going to cancel. Like, I always look to say, did I get lucky? Did maybe the x's were 2 and negative 2, or y's were 4 and negative 4? Nope. But this time they're both, like, that one, it was really nice to say, hey, times 2 is going to be negative 4, matches that, good to go. This one, and for some reason the x's are catching my attention, I can just... This is 2 and 3. I'm going to turn those both into 6's. That means I'll multiply this entire equation by 3 and this entire equation by 2. Please notice that my sign, our sign, will be good, because this will turn out to be 6x. This will be negative 6x. That's what I want. Okay? So the top equation becomes 6x minus 12y negative 30. Okay? Be careful. Always make sure to get that number over there. People kind of forget that sometimes. Here, negative 6x plus 12y. See what's coming here? And then that's negative 42. I'll add those two equations together. The x's cancel and the y's cancel, giving us 0 over there. You have to cancel means they go to 0, because 6 plus negative 6 is 0. Negative 12y plus 12y is 0. And negative 30 plus negative 42 is negative 72. Now, you remember the example earlier. The statement was true. Negative 12 equals negative 12. That's not true. 0 does not equal negative 72. This is no solution. That means if we were to graph these two lines, they would be perfectly parallel and never cross each other. Okay? So there you have it. Again, totally review lesson. There's nothing wrong with a little review lesson and something that's not too super challenging. The following week will be our last assignment, our last group, and like I said, we're going to be dealing with systems that aren't just straight lines anymore. They're going to be parabolas and cubic functions, and could be lines still, but it's going to be a combination of the two, and that's what the examples will look like next week. All right, so that should get you through the worksheet that I send to you, and should be a pretty okay assignment for a 4-day week, because Monday's Memorial Day. All right, take care, people.